Hi students, today we are going to discuss exercise 6.7, very important exercise, and find the equation of the plane. There are three types. The first one type, equation of a plane passing through a given point and parallel to two given non-parallel vectors. Find the equation of the plane passing through one point and two parallel. One point and two parallel. Find the equation of the plane. First one, parametric form of vector equation, and the second one, non-parametric form of vector equation, and third one, Cartesian equation. Find the three formula. Equation of the plane passing through given a one point and two parallel. One point and two parallel. That is a plane, XY plane. That is a plane. The plane is the origin O. Given one point and two parallel. Let A be any one of the point in a plane. Let A be any one of the point in a plane. Let OA vector equal to OA vector equal to A vector. OA vector equal to A vector. Let P be any point on the plane. Let P be any point on the plane. That is OP vector equal to R vector. OP vector equal to R vector. Given one point and parallel to two given non-parallels. Two parallel lines. That is this one parallel U vector. This one parallel V vector. One point and two parallel. One point and two parallel. Equation of a plane in vector form. First one, parametric form of vector equation. Parametric form of vector equation is R vector equal to A vector plus SU vector plus TV vector. R vector equal to A vector plus SU vector plus TV vector is a parametric form of vector equation, where S and T are parameters. That is a parametric form of vector equation. The next one, non-parametric form of vector equation. Non-parametric form of vector equation is R vector minus A vector. R vector minus A vector dot U vector cross V vector equal to 0. That is a non-parametric form of equation of plane is R vector minus A vector dot U vector cross V vector equal to 0 is a non-parametric form of equation of plane. The next one, Cartesian form. Cartesian form. This is a Cartesian form is given one point and two parallel. Given the point is x1, y1, z1 be the one of the point. x1, y1, z1 be the one of the point. And the parallel U vector and V vectors are two parallel. Where parallel is, first one parallel is L1, M1, N1. And the second parallel is L2, M2, N2. Now write in a Cartesian form is given one point is x minus x1, y minus y1, z minus z1. And the first parallel is U vector is L1, M1, N1, that is the point. L1, M1, N1. And the second parallel is L2, M2, N2 equal to 0. That is a Cartesian form is x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0 is a Cartesian form of equation of a plane. And next one formula, equation of a plane passing through two given distinct points and is parallel to a non-zero vector. Equation of a plane passing through two distinct points and is parallel to non-zero vector. So find the equation of the plane passing through two distinct points and a parallel vector, one of the parallel. Given 2 point and 1 parallel. Given 2 point, 1 parallel, find the parametric form of vector equation, Cartesian form of vector equation, and non-parametric form of vector equation. Now find the three formulas. Given two distinct points, that is a plane. That is a point is O be the origin. Given two distinct points, let A be any one of the points. Let OA vector equal to A vector, small a vector. And the point B, another one point lie on the plane. Let OB vector equal to B vector. OB vector equal to B vector. and P be the any point on the plane, let OP vector equal to small r vector, OP vector equal to r vector. That is the plane given 2 points, A be the one of the point and B be the another one point, given 2 points and one parallel. That is the parallel is, this one is parallel, U vector be the one of the parallel. Given 2 points and one parallel, find the parametric form of vector equation, non-parametric form of vector equation and Cartesian equation of the plane. So find the 3 formulas. First now write in here parametric form of vector equation. Parametric form of vector equation, r vector equal to, given 2 points, A be the one of the point, r vector equal to A vector plus S of B vector minus A vector. B vector minus, where B vector be the second point. R vector equal to A vector plus S of B minus A plus T of U vector, where U is the parallel. Equation of plane passing through two given distinct points and is parallel to non-zero vector. That is, given 2 points, A and B are 2 points, U be the one of the parallel. That is a parametric form of vector equation is R vector equal to A vector plus S of B minus A plus T of U, parametric form. The next one, non-parametric form of vector equation is non-parametric form. R vector minus A vector, R vector minus A vector dot B vector minus A vector, R vector minus A vector dot B vector minus A vector cross U vector equal to 0. That is a non-parametric form of vector equation. R vector minus A vector dot B vector minus A vector cross U vector, U is the parallel, equal to 0. That is a non-parametric form. Here the parameter S and T are parameter. That is a non-parametric is non-parametric form. R vector minus A vector dot B minus A cross U vector equal to 0 is a non-parametric form. And the third one, Cartesian form. Cartesian form of vector equation, given 2 points. That is, the point is, here the point A vector equal to x1 I vector x2j plus x3k. Here the point is A is x1 y1 z1 be the one of the point is A, and another one point is x2 y2 z2 be the second point, and the parallel vector is U vector is L M N are parallel. Now write in a Cartesian form using determinant, that is a determinant of x minus x1, y minus y1, z minus z1, and second row write in x2 minus x1, y2 minus y1, z2 minus z1, and the third row is parallel L M N equal to 0 is a Cartesian equation of the plane. This x minus x1, y minus y1, z minus z1, second row x2 minus x1, y2 minus y1, z2 minus z1, the third row L M N equal to 0 is a Cartesian form of the equation of the plane. Next, third formula. Equation of a plane passing through 3 given non-collinear points. Equation of a plane passing through 3 non-collinear points. That is the plane. That is the plane. A be the one of the points. Let O be the origin. OA vector equal to A vector. OA vector equal to A vector. And second point B. That is the point is B, and the third point is C. That is the point is C. Let P be any points, and the plane is OP vector equal to R vector, and OB vector equal to B vector, and OC vector equal to C vector. Now we join the line. That is the equation of the plane. Find the equation of the plane given 3 points, 3 non-collinear points. 3 non-collinear points. First now write in here parametric form of vector equation. Parametric form. First one write in parametric form of vector equation. R vector equal to A vector plus S of B vector minus A vector plus T of C vector minus A vector. The parametric form of vector equation, R vector equal to A vector plus S of B minus A plus T of C vector minus A vector, that is a parametric form. The next one, non-parametric form. Non-parametric form R vector minus A vector, R vector minus A vector dot B vector minus A vector cross C vector minus A vector equal to 0. R vector minus A vector dot B vector minus A vector cross C vector minus A vector equal to 0, or then box plot of R vector minus A vector, B vector minus A vector, and C vector minus A vector equal to 0 is a non-parametric form of vector equation. And third one, Cartesian equation, Cartesian form. And Cartesian form, given three non-collinear points. The first point A of x1, y1, z1, and the point B is x2, y2, z2, and the point C of x3, y3, z3 is the third point. Now write in a Cartesian form with determinant form x minus x1, y minus y1, z minus z1, and the second one x2 minus x1, y2 minus y1, z2 minus z1, and the third row x3 minus x1, y3 minus y1, and z3 minus z1 equal to 0 is a Cartesian equation of the plane. There are three forms: parametric form, non-parametric form, and a Cartesian form. These are the equation of the plane passing through three given non-collinear points. That is, first one is parametric form R vector equal to A vector plus S of B minus A plus T of C vector minus A. Non-parametric form R vector minus A vector dot B vector minus A vector cross C vector minus A vector equal to 0. And the Cartesian form, this one 3 points x minus x1, y minus y1, z minus z1. And second row x2 minus x1, y2 minus y1, z2 minus z1. Third row x3 minus x1, y3 minus y1, and z3 minus z1 equal to 0 is a Cartesian equation of the plane. Next one, exercise 6.7, very important exercise. The first problem, find the non-parametric form of vector equation and the Cartesian equation of the plane passing through the point 2, 3, 6 and parallel to the straight lines x minus 1 by 2 equal y plus 1 by 3 equal z minus 3 by 1, and x plus 3 by 2 equal y minus 3 by minus 5 equal z plus 1 by minus 3. Find the equation of non-parametric form and the Cartesian equation of the vector equation. The line is passing through the point, given one point. The one point is 2, 3, 6. One point and parallel to the straight line. And parallel to the straight line means that is a parallel, that is the equation of the straight lines. We want the parallel only. Already you know the Cartesian, that is a Cartesian form. The Cartesian form in numerator, that is a point. Numerator is a point. And the denominator is parallel. Denominator is a parallel. That is a formula is x minus x1 by b1, y minus y1 b2, z minus z1 by b3. That is b1, b2, b3 is the parallel. So the line is parallel to the passing through the point and parallel to the straight line. That is a parallel means this one. 2, 3, 1 is the one of the parallel. And the second one, like Cartesian form in equation of a straight line, x minus x1 by d1, y minus y1 by d2, z minus z1 by d3. That is the one of the straight line. That is a parallel is 2 minus 5 minus 3 is the parallel. So what is given? 1 point and 2 parallel. 1 point and 2 parallel. Find the equation of plane, parametric form and Cartesian equation of the plane. 1 point and 2 parallel, already you know the formula. 1 point and 2 parallel, that is in the parametric form is R vector equal to A vector plus S of B vector, S of U vector plus T of V vector. R vector equal to A vector plus S of U, where U is the parallel and V is the parallel. R vector equal to A vector plus S of U plus T of V. And non-parametric form is R vector minus A vector dot R vector minus A vector dot U vector cross V vector equal to 0 is a non-parametric form. And the Cartesian form is given 1 point. This is a Determinant of x minus x1, y minus y1, z minus z1, and the parallels are L1, M1, N1, L2, M2, N2 equal to 0 is a Cartesian equation. Now what is given? Now write in the 1 point and 2 parallel. This 1 point and 2 parallel. That is the point is, now write in a vector. That is given. A vector equal to, now write in a vector form 2i vector plus 3j vector plus 6k vector. This is a 1 point and 2 parallel. That is a one of the parallel and this one is second parallel. This write in a u vector equal to 2, 3, 1 is 2i vector plus 3j vector plus k vector is u vector, one of the parallel. And v vector equal to second parallel 2i vector minus 5j vector minus 3k vector, that is a 1 point and 2 parallel. First now find the non-parametric form of vector equation. Non-parametric form of vector equation. Already you know non-parametric form of equation, r vector minus a vector dot u vector cross v vector equal to 0. R vector minus a vector dot u vector cross v vector equal to 0. Now find u vector cross v vector. Find u vector cross v vector. Find u vector cross v vector is this u vector cross v vector equal to u vector, u and v are two vectors. That is u cross v is vector product of two vectors. Now write in a determinant form I vector, j vector and k vector. The component of u is 2, 3, 1. 2, 3, 1. And the component of v is 2, minus 5, minus 3. Now expanding the determinant. I vector into 3 into minus 3, minus 9. Already formula is minus 5 into 1, minus 5, formula is minus half, minus plus. Next one, taking the element j, minus j vector into, getting the mathematic 2, 1, 2, minus 3. 2 minus 3, 2 into minus 3, minus 6. Formula is minus 2 ones are 2. Plus k vector into, column and row are eliminated, getting the minor matrix. 2 into minus 5, minus 10. 2 3s are 6, minus 6. That is equal minus 9 plus 5, minus 4 I vector. Next one, minus 6, minus 2, minus 8, minus half, minus plus 8 j vector. Next one, plus k of minus 10, minus 6, minus 16 k vector is u vector cross v vector. Now substitute in non-parametric form. R vector minus a vector dot u vector cross v vector equal to 0. R vector, that is the parametric form, non-parametric form. R vector minus a vector is 2i vector plus 3j vector plus 6k vector dot u cross v is minus 4i vector plus 8j vector minus 16k vector equal to 0 is a non-parametric form of vector equation. And next find Cartesian equation of the plane. Cartesian equation of the plane. So Cartesian form. Given 1 point and 2 parallel, that is the point is x1, y1, z1 be the point. The point is 2, 3, 6, 2, 3, 6, and L1, M1, N1 equal 2, 3, 1, and L2, M2, N2 equal to 2, minus 5, minus 3. That is the 1 point and 2 parallel. Now write in a Cartesian form is x minus x1, y minus y1, z minus z1, and parallel L, M, L1, M1, N1, L2, M2, N2 equal to 0. Equal to 0 is a Cartesian form. Now substitute in the point x minus x1. X minus x1 is 2. Y minus 3. That is the point y1 is 3. And z minus 6. L1, M1, N1 is 2, 3, 1. L2, M2, N2 is 2, minus 5, minus 3 equal to 0. Now expanding the determinant, expanding x minus 2 into 3 into minus 3, minus 9, formula is minus 5 into 1, minus 5, minus half, minus plus 5. X1 minus of y minus 3 into minus of y minus 3 into 3 minus 3 into 2 minus 6, 2 ones are minus 2, minus 2. X1 plus z minus 6 into minus 5 into 2 minus 10 minus 6 equal to 0. That is implies minus 9 plus 5 minus 4 x minus 2 into minus 4 minus of y minus 3 into minus 8 plus z minus 6 into minus 16 equal to 0. The next one implies multiply minus 4 into x minus 4x minus into minus plus 4 2s are 8. Next one multiply by minus into minus plus 8 into y plus 8y. Next one minus into minus plus into minus 8 3s are 24. Next one minus into plus minus 16 into z 16z. Next one minus into minus plus 16 into 6 96 equal to 0. That is implies minus 4x plus 8y minus 16z minus 4x plus 8y minus 16z. Next constant term minus, that is 96 plus 8 104 minus 24 4 minus 4 0 next one 10 minus 2 80. That is plus 80 equal to 0. Minus 4x plus 8y minus 16z plus 80 equal to 0. This equation is divided by minus 4. This equation is divided by minus 4. That is implies x 1 4s are 4 x minus 2 4s are 8 minus 2y. Next one minus half minus plus 4z 4 4s are 16 4z. Next one 80 20 into 4 80 minus 20 equal to 0 is here Cartesian equation of the plane. Next one, second problem. Find the parametric form of vector equation and the Cartesian equations of the plane passing through the points 2, 2, 1, 9, 3, 6 and perpendicular to the plane 2x plus 6y plus 6z equal to 9. Now find the parametric form of vector equation and the Cartesian equation of the plane passing through 2 points. And perpendicular to the plane. That is a perpendicular to the plane means that is a parallel to the line. That is a parallel. Now I am taking 2x plus 6y plus 6z equal to 9. That is a equation of the plane. Now writing here perpendicular vector is 2y vector plus 6j vector plus 6k vector is a perpendicular vector. Perpendicular vector is also a parallel vector. That is a parallel vector is 2y vector plus 6j vector plus 6k vector is a parallel vector. Given 2 point and 1 parallel. 2 point 1 parallel equation of the plane. First one find the parametric form of vector equation. Parametric form of vector equation is 2 points. R vector equal to A vector plus S of B minus A plus T of U vector, where U is the parallel. It is a parallel vector. And the Cartesian form is Cartesian equation. Cartesian equation given 2 points is x minus x1, y minus y1, z minus z1. And the second row x2 minus x1, y2 minus y1, z2 minus z1, L, M, N, where L, M, N are parallel equal to 0. That is a Cartesian form. Now, given the points, one of the point A and B are 2 points. Given the first one point is writing a vector equal to 2I vector plus 2j vector plus k vector. And the second point B vector equal to P vector equal 9I vector plus 3j vector plus 6k vector. First one point 2I plus 2j and k, 1k, 9I vector, 3j vector plus 6k vector is that is second point. And the parallel vector is, and the perpendicular to the vector is, perpendicular vector 2I vector plus 6j vector plus 6k vector is a perpendicular. The perpendicular vector is also a parallel vector. Therefore, the parallel vector U vector equal to 2I vector plus 6j vector plus 6k vector is the parallel vector. 2 point and 1 parallel, the parametric form of vector equation, the parametric form of vector equation R vector equal A vector plus S of B vector minus A vector. R vector equal to A vector plus S of B minus A plus T of U vector. T of U vector, that is one of the formula. Now substituting R vector equal, here A vector value, A vector is 2I vector plus 2j vector plus k vector plus S of B minus A. Here B minus A is 9 minus 2, 9 minus 2, 7I vector. Next 3 minus 2, 1 into j vector. 6 minus 1 is 5 plus 5k vector plus T of U vector. Here U vector is 2I vector plus 6j vector plus 6k vector. That is a parametric form of vector equation. Parametric form of vector equation. Now next find Cartesian equation. Next find Cartesian form. Cartesian equation. The plane is, there is a point given 2 points. First one point x1, y1, z1 equal to 2 to 1, 2 comma 2 comma 1, and x2, y2, z2 equal to 9 comma 3 comma 6, and L, M, N equal to, that is a parallel 2, 6, 6, 2 comma 6 comma 6, that is a parallel. Now write in a Cartesian formula, determinant of x minus x1, y minus y1, z minus z1, and the second point, second row, x2 minus x1, y2 minus y1, z2 minus z1, L, M, N equal to 0 is a Cartesian form. Now substituting x1, y1, z1, x2, y2, z2. It is a determinant of x minus x1, x1 value 2, x minus 2, x1, y minus 2, and z minus 1. x1, x2 minus x1, x2 minus x1 is 9 minus 2, 7, 3 minus 2, 1, 6 minus 1, 6 minus 1 is 5. x1, L, M, N, 2, 6, 6 equal to 0. Now expanding the determinant, that is implies x minus 2 into, getting the minor matrix, 6 ones are 6, 6 minus 5 6 are 30, 6 5s are 30. Next minus of y minus 2 into, y minus 2 into, column under row element, getting the minor matrix 7 5 2 6, 7 6 are 42, minus formula is minus, 5 2s are 10, 5 2s are 10. Next one plus z minus 1 into z minus 1 into, getting the minor matrix 7 6 are 42, minus 2 1s are 2, equal to 0, equal to 0. That is implies x minus 2 into 6 minus 30, 6 minus 30 minus 24, minus 24, minus of y minus 2 into 42 minus 10, 32, 32, plus z minus 1 into 42 minus 2, 42 minus 2 is 40, equal to 0. Now multiply minus 24 in both terms, minus 24x, minus into minus plus, 24 into 2, 48, 48 minus y minus 32y minus 32y minus into minus plus 32 into 2 60 plus 64 plus 64. Next one plus 40 into z, 40z minus 40 equal to 0. Minus 24x now write in here xyz. That is implies minus 24x minus 32y minus 32y plus 40z and the next one constant term 48 plus 48 minus 48 minus 48 plus 8 64 plus 8 72 that is plus 72 equal to 0 minus 24x minus 32 this value is divided by 4 divided by minus 4 divided by minus 4 that is implies 8 3s are 20 6 4s are 24 6x plus 8 4 32 8y plus 8y. Next one minus divide by minus 4 minus 10z minus 10z. Next one plus and minus 72 by 4 1 4s are 4 remaining 3 1 4s are 4 remaining 3 32 8 4 32 8 18 equal to 0 6x plus 8y minus 10z minus 18 equal to 0 is the Cartesian equation of the plane. The next problem, sixth one, find the parametric vector, non-parametric vector and Cartesian form of the equation of the plane passing through three non-collinear points 3, 6, minus 2, minus 1, minus 2, 6 and 6, minus 4, 2. Find the parametric vector equation and non-parametric vector equation and Cartesian equation of the plane. Given three non-collinear points. Already you know the formula. Equation of a plane passing through three non-collinear points or three given points. Parametric form of vector equation is r vector equal to a vector plus s of b minus a plus t of c minus a is the parametric form of vector equation. The next one, non-parametric form of vector equation is r vector minus a vector dot b vector minus a vector cross c vector minus a vector equal to 0 is a non-parametric form of vector equation. And next one, Cartesian form of the equation of the plane is determinant x minus x1, y minus y1, z minus z1. x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1 is the Cartesian form of the equation of the plane. Now find the parametric form, non-parametric form and the Cartesian form. So given 3 points, write in here. First point is A. Here write in A vector equal to 3i vector plus 6j vector minus 2k vector. This is A vector. And B vector equal minus I vector minus 2j vector plus 6k vector. This is B vector. And C vector is 6i vector minus 4j vector minus 2k vector. Given 3 points, write in a vector A, B and C. First now find out parametric form of vector equation. Parametric form of vector equation is a parametric form. Parametric form of vector equation is R vector equal A vector plus S of B vector minus A vector plus T of C vector minus A vector. This is a parametric form. R vector equal to A vector plus S of B minus A plus T of C minus A. That is equal, right? R vector equal A vector. Here A vector is 3i vector plus 6j vector minus 2k vector plus s of b minus a. Here b minus a is b minus a minus 1 minus 3 minus 1 minus 3 minus 4 I vector. Next one minus 2 minus plus and minus 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 2 minus 6 minus 8 j vector. Next one 6 minus half minus plus 6 plus 2 8 plus 8 k vector plus t of c minus a. C minus a, c vector minus a vector. 6 minus 3, 6 minus 3 is 3. 3 I vector. Next one, minus 4 minus 6, minus 4 minus 6, minus 10 j vector. Next one, minus 2. Next already minus half minus plus. Minus 2 plus 2, values is 0. Values is 0. That is R vector equal to 3i plus 6j minus 2k plus s of minus 4i minus 8j plus 8k vector plus t of 3i minus 10j is the parametric form of vector equation. Next find non-parametric form of vector equation. This is a non-parametric form of vector equation. Non-parametric form. Non-parametric form of vector equation already know formula. R vector minus a vector dot b vector minus a vector cross c vector minus a vector equal to 0 is a non-parametric form of vector equation. Now substituting r vector minus a vector, r vector minus a vector, r vector minus, here a vector is 3i vector plus 6j vector minus 2k vector dot b vector minus a vector, b minus a is minus 4i minus 8j vector plus 8k vector cross c minus a is 3i minus 10j, 3i vector minus 10j vector is c minus a. First now multiply b minus a cross c minus a vector. Therefore vector product of two vectors. Vector product of two vectors by using determinant form. B vector minus a vector cross c vector minus a vector equal determinant of I vector, j vector and k vector. The component of b minus a is this one. The component of b minus a minus 4 minus 8 plus 8. And the component of c minus a is 3 minus 10 and 0. The component of k is 0. And this is now expand the determinant I vector into getting the minor matrix minus 8 into 0 is 0. Next formula is minus 10 into 8 minus 80, formula minus half minus plus 80. Next taking the element j vector minus j vector into column under row are eliminate getting the minor matrix minus 4 into 0 is 0. Next one formula is minus 8 3s are 24 minus 24. Next one taking the element k vector k column under row are eliminate getting the minor matrix minus 4 minus 8 3 minus 10 minus into minus plus 10 into 4 40. Formula minus 8 into 3 into minus 8 minus 24. This minus half minus plus 24. This equal 80 I vector minus into minus plus 24 j vector plus 40 plus 24 64 k vector. That is a b vector minus a vector cross c vector minus a vector equal to 80 I vector plus 24 j vector plus 64 k vector. Now substituting this one, that is a non-parametric form, r vector minus a vector, r vector minus, here already writing a vector is 3i vector plus 6j vector minus 2k vector dot b minus a cross c minus a, this one 80 I vector plus 24j vector plus 64k vector equal to 0. Now 80I vector plus 24j vector plus 64k, 80, 24, 64 is divisible by 8. The whole equation is divisible by 8. This r vector minus 3I vector plus 6j vector minus 2k vector dot divide by 8. All divide by 8 is 10, 8, 80, 10I vector plus 3 times, 3 8s are 24, 3j vector plus 64 is 8, 8 are 64, 8 k vector equal to 0 by 8, divide by 8, that side values is 0. So r vector minus 3I vector, r vector minus 3I vector plus 6j vector minus 2k vector dot 10I vector plus 3j vector plus 8k vector. Now dot product of this vector, this one is, write in dot product of, first one write in r vector dot, this one, r vector dot 10I vector plus 3j vector plus 8k vector, first one. Next minus a vector dot 3I plus 6j minus 2k dot product of this one vector, 3I vector plus 6j vector minus 2k vector dot this one, 10I vector plus 3j vector plus 8k vector equal to 0. Now dot product of r vector dot 10I vector plus 3j vector plus 8k vector minus dot product of two vectors, 10 into 3 30, next 6 into 3 18 plus 18, 8 into minus 2 minus 16 equal to 0. That is r vector dot 10I vector plus 3j vector plus 8k vector minus 30 plus 18 minus 16, 18 minus 16 plus 2, 30 plus 2 32, outside is minus 32 equal to 0. That is a non-parametric form of vector equation. Next to find Cartesian form. Cartesian equation is, that is a Cartesian equation. Cartesian form of the equation x and y z is a Cartesian equation of the plane. Given, now get the answer, r vector dot 10I plus 3j plus 8k minus 32 equal to 0 is a non-parametric form of vector equation. Now find the Cartesian form is, let the value r vector equal to xi plus yj plus zk, substitute in r vector, let r vector equal to xi vector plus yj vector plus zk, substitute in r vector. This is xi vector plus yj vector plus zk vector dot 10I vector plus 3j vector plus 8k vector minus 32 equal to 0. Now dot product of two vectors, 10 into x is 10x plus 3y plus 8 into z is 8z minus 32 equal to 0 is a Cartesian equation of the plane. 10x plus 3y plus 8z minus 32 equal to 0 is a Cartesian equation of the plane.